You know that absolute sinking feeling when your network-attached storage just completely drops off the map? Welcome to today's Explainer, where we're going to unravel a wild diagnostic mystery that has frustrated so many NAS owners. It's a classic tale of miscommunication between pieces of hardware that look completely broken, but honestly, they just need the right translator. Picture this incredibly stressful, yet very specific scenario. You've got a 3 terabyte Western Digital MyBook Live, specifically the WD-BACG0030HCH-00 model. Out of nowhere, it won't connect to the network. It powers on, sure, but you can't even tell if the drive is actually spinning inside. So you try directly connecting it to your laptop via the LAN port, which is the only port on the thing. Your laptop sees a device is attached, but it can't recognize or read it. Finally, you do what any logical tech-savvy person would do. You extract the physical drive, attach it to a SATA adapter, and plug it right into an Ubuntu Linux laptop to rescue your files. But instead of your data, you hit a massive brick wall. You are immediately slapped with this terrifying error message. It basically screams at you: error mounting file system, wrong FS type, bad option, bad superblock on /dev/stc4, missing code page or helper program, or other error. I mean, it literally spits out an error string, making it look like your data is toast. And look, seeing the words bad superblock is usually enough to strike fear into the heart of anyone doing data recovery. Okay, let's alleviate that panic right off the bat. Your hard drive is actually perfectly fine. The platters are healthy, your files are intact, and your data hasn't vanished into the ether. Your drive is simply speaking a language that your desktop's operating system fundamentally misunderstands. All right, Section 1. The setup, the dead NAS dilemma. Let's look closer at what's happening. So, going back to our setup, your WD MyBook Live drops off the network and flashes those dreaded yellow and blue lights of death. You extract it, use the SATA adapter, and plug it into Ubuntu. And here is where it gets really weird. Ubuntu does see the device. It successfully reads the exact model, the total size, the GUID partitioning, and the serial number. The physical hardware connection is undeniably working, and yet Ubuntu just flatly refuses to mount the data. If we peek at the drive's internal layout, it uses a GUID partition table that separates the operating system from your user data. Ubuntu has no problem recognizing the first two 1.9 gigabyte X3 operating system partitions, which, by the way, are arranged in a RAID 1 mirror. It also sees the 489 megabyte memory swap partition. But it's that massive 2.7 terabyte X4 data partition at the very end, usually sitting at /dev/SDA4 or STC4, that contains your actual files, and that is what triggers the ugly error. Which brings us to Section 2, the twist, the Ubuntu mounting mystery. If you ignore that initial pop-up window and run a system diagnostic tool like DMES in your terminal, you uncover a vital clue hidden right in the system logs. It says, EXT4FS, bad block size 65,536. This right here is the actual reason the mount is failing. It's not corruption at all. So let's crack this case wide open in Section 3, the reveal, the 64 KB block villain. What we're looking at is a classic square peg in a round hole problem. When Western Digital designed the specific MyBook Live, they put an AMCC PowerPC processor inside the enclosure. To minimize processing overhead and squeeze out the absolute maximum gigabit Ethernet transfer speeds, they configured the ext4 file system with a massive 64 kilobyte block allocation size. The PowerPC chip loves this. It handles it perfectly. But your standard desktop computer, your x86 Ubuntu machine, it is hard-coded to a strict 4 kilobyte memory page size. They are completely incompatible. And that clash triggers a hard limitation in the core Linux kernel, specifically within the virtual file system, or VFS layer. There is a very strict rule in Linux. A file system's block size absolutely cannot exceed the hardware memory page size of the CPU running the kernel. Because of this rule, the VFS layer flat out refuses to mount a 64 KB block on a 4 KB CPU. That is exactly why it generates that terrifying yet totally misleading bad superblock error. Now, because of this weird architecture, here is a massive warning about what you absolutely must not do next. Do not try sticking this extracted drive into a different brand's NAS enclosure, like a Synology or a QNAP, thinking it'll magically fix it. Beyond just the block size issue, Western Digital uses proprietary metadata and LVM layouts. A third-party NAS won't recognize the array and will immediately prompt you to initialize and format the drive. If you click yes, your data is gone forever, literally wiped out. Okay, so how do we get around this? Let's move to Section 4, bypassing kernel limits. The solutions. The clever workaround here is something called Fuse, which stands for File System in User Space. Because Fuse operates entirely outside the restrictive, hardware-bound kernel space, it basically acts as a software translator. It neatly sidesteps your CPU's memory page limits, finally allowing your standard 4KB Ubuntu laptop to parse and read those giant 64KB ext4 blocks. So here's the magic trick. Open your terminal. Step 1, you install the Fuse driver by typing sudo apt-get install fuse x2. Once that's done, step 2 is to force the mount in read-only mode using the command shown here, making sure to point it to your specific data partition like /dev/sdc4. By running this, you're telling Ubuntu to mount the partition via user space instead of the kernel. Boom! Suddenly that dead drive is accessible, giving you read-only access to copy all those precious files over to a safe drive. But what if you don't even want to mount it? Section 5, Alternative Extraction Methods. No mounting required. You actually don't have to mount the file system at all to rescue your data. You can leverage powerful Linux developer debugging tools like debugfs or the eTools suite. These tools are incredible because they read the raw extend4 structures directly from the disk image, completely bypassing the kernel's stubborn mounting rules. Honestly, this is highly recommended if you suspect the partition table might have taken a little damage when the NAS originally failed. Doing this is surprisingly straightforward. First, you just open debugfs with root privileges. Then you manually force the debugger to expect the large block size by typing open-b 65536, followed by your partition like SDC4. Once you're inside, you can navigate your folders just like normal and use the rdump command to securely extract entire directories, like, say, your shared music folder, straight to your laptop's desktop backup folder. Now, keep one important thing in mind while you're celebrating getting your data back: your speed. Because you're using software translation layers like Fuse or user space debuggers instead of native kernel drivers, your transfer speeds are going to be throttled pretty heavily. You're probably going to see speeds around 20 megabytes per second. So if you're rescuing a full 3 terabytes, you're definitely going to need some patience. Go ahead and put on a pot of coffee. It's going to take a while. And finally, Section 6. Rescuing your data, the final takeaway. Ultimately, that panic-inducing bad superblock error was a total red herring. It was never a death sentence for your hard drive. By just understanding the architectural clash between Western Digital's 64KB PowerPC design and your desktop's 4KB x86 limits, you've successfully turned a highly stressful hardware crisis into a completely solvable data recovery operation. Your data was always right there, just waiting for you to step in as the interpreter. And honestly, this weird technical quirk leaves us with a fascinating final thought to ponder. The next time a piece of technology throws a terrifying error or just flat out refuses to communicate, is it actually broken? Or is it simply waiting for you to find the right way to speak its language? Thanks for joining me on this explainer, and hey, happy data rescuing!